Hello everybody, and this is the second part of the videos on trig substitutions. I did one video on trigonometric substitution with an example, and this is just a continuation of that. In that example we saw how we can break down an expression that involves square root of 1 minus x squared by replacing x by cos theta. And as you can see, 1 minus x squared breaks down to 1 minus cos squared theta, which turns into 1 minus cos squared theta, which becomes sine squared theta, and the square root of that becomes sine theta. That makes the trig substitution very useful in integrating expressions of this kind. So now I'll be continuing to give you, I will still say introduction, but general ideas on how we start the problem, on how we do the primary substitution, the initial substitution. Okay, so to keep in mind, sine squared theta is 1 minus cos squared theta. So if I have 1 minus x squared, it will look like this or this one. And here sec squared theta is 1 plus tan squared theta. As you can see, that would be an ideal substitution for square root of 1 plus x squared. And for this guy, sec squared theta minus 1, well, this is an ideal substitution for x squared minus 1. So I'm going to have kind of general idea on kind of table for the substitutions. Okay, so we saw that if I have an expression, if I have an expression that involves 1 minus x squared, we use x equals sine theta, or equally x equals cosine theta. In the previous example I used x equals cosine theta, and either one works perfectly well, no problem, and no advantage or disadvantage. Okay, so if x is sine theta, then dx becomes cosine theta d theta, or if x is cosine theta, dx becomes negative sine theta d theta. So be careful that you need to replace, substitute the dx part, like this guy here, by the appropriate expression. Okay, not only that you replace the x's, but also the dx part. Okay, and now what this gives us is that 1 minus x squared, 1 minus x squared is the square root of 1 minus sine squared theta. This is cos squared theta, so it will be square root of cosine squared theta, which is cosine theta for the appropriate values of theta. If theta is in the fourth and first quadrant, then this is positive, so that square root becomes that one. The square root becomes just plain cosine theta. We don't need to worry about it in this lesson, because in this section, because the thetas are selected properly. And in this case here, if x is cosine theta, the square root of 1 minus x squared, as we saw in the first example, becomes sine theta. Okay, now I'm going to add a few more expressions. 1 plus x squared, we use x equals tangent theta, then dx will be sec squared theta d theta. Okay, and the square root of 1 plus x squared becomes the square root of 1 plus tan squared theta, which is the square root of sec squared theta, and this is secant of theta for the right values of theta. Okay, if our expression has something that looks like this x squared minus 1, okay, you can see that this is something that resembles 6 squared theta minus 1. So I'll be using x equals, you use x equals secant of theta. Then dx is sec theta tan theta d theta, and the square root of x squared minus 1 becomes, oh, this is an ugly square root, so long. Okay, so the square root of x squared minus 1 becomes the square root of sec squared theta minus 1, or the square root of tan squared theta, or tangent of theta. Okay, I'll add a couple more cases. Let's say I have 4 minus x squared. What would I do instead of 1 minus x squared? Well, if we go back to our trig expressions, each one has a 1 minus or 1 plus or 6 squared minus 1. None of them have 4. But this guy looks like 4 minus x squared, or so somewhat one of these. So we can see that the sine theta is the right, or the cosine theta is the right function to use. Okay, the only thing we have is that how do we deal with the 4? And in this case we use x equals 2 sine theta, or 2 cosine theta equally works. Okay, and in this case dx becomes 2 cosine theta d theta. And not only that, we can see that 4 minus x squared now is 4 minus x squared, this guy squared. What's this guy squared? This guy squared is 4 sine squared theta. Factor out the 4, you get 1 minus sine squared theta, or cosine squared theta. So the square root of 4 minus x squared simplifies to 2 cosine theta. Okay, let me fix this. 2 cosine theta. I'll add a couple more examples. I have, let's say, 1 minus, I don't know, 1 plus 9x squared. What if the number is by x squared and not by 1? And in this case, use 3x equals, you see that the appropriate function is a tangent function. So you're tempted to use x equals tan theta, but because of the 3, here's what I do. I use 3x equals tan theta, and therefore 9x squared will be tan squared theta, and it works very well if you use when you do the substitution. So 3dx is sec squared theta d theta. So remember, this is not dx, this is 3dx. So you're going to have to solve for dx before you apply this one. Okay. Let me add one more example. Let's say I have 4 minus 9x squared. And in this case, the function that I'll be using will be either sine or cosine, and I have this 9x squared and this is 4. Well, in this case I would be using 3x equals 2 sine of theta, or 2 cosine of theta. And if you work this out, it works out perfectly well. Dx becomes 2/3 of cosine theta d theta. So you solve for dx, and in this case here you would do dx equals 1/3 of secant squared theta d theta. I hope this introduction helps, and I hope you can continue doing the exercises from the book. Thank you and goodbye.